recording. So yeah, what we'll do is we'll go through a bunch of tan graphs because I know that like where to put the asymptotes and where to put the y values and the amplitudes, even though there is no amplitude and all that kind of stuff. It gets people a bit mixed up. So we'll cover that today. Just kind of fix that. Alright, cool. So the basic tan graph, I mean, you got the whole graph, so I'm just going to do maybe between 0 and 2 pi, as we know that that's the most common one. So we'll start us off like this, and as I've been talking about, that's 2 pi, and then from that we can now cut it in half, that's pi. From that we've got pi over 2, and 3 pi over 2. So there's our 5, like I say, anchor points, the 5 important bits. From that we can find all the important bits of each of the sine, cos, and tan graphs. From there we can then go ahead and do any squishing or anything we need to do. So, what happens at 0? Well, yeah, but like, what's the point at 0? 0. Yeah. Alright. What's the point at pi over 2? It's an asymptote, yeah, so it's not really a point. So we have our asymptote. What's the point at pi? So another 0. What's the point at 3 pi over 2? Another asymptote. What's the point at 2 pi? Another 0. So, as I've said with sine, cos, and tan, what you want to remember first of all is what happens at each of those 5 things. 0, pi over 2, pi, 3 pi over 2, 2 pi. Good to go. And then, so what happens in each of these in each of these sections is they're kind of like mini cubic functions in a way. So they go like this, and I'll talk about the y values in a second because I think that's something that we need to focus on more than anything when we talk about the tan graphs. And then we just do it again, and then we just do it again. Alright, so there is our tan graph, except the problem is we don't have any values on our y-axis, and you can't just put the 1 anywhere, it needs to be at the right place, okay? So we need to figure out, well, where we're going to put our 1. The way that we're going to do that, and the 1 and then also the negative 1, I guess, as well, although really, you only need 1 value on the y-axis. We just generally do 1 and negative 1, or whatever the range is, because sine graphs and cos graphs kind of go between those two, whereas tan, it goes on forever, so yeah, really. But anyway, where we're going to put that 1 is, I'm going to put it there, and there's a reason why I'm doing that, okay? If that's pi over 2 here, where's pi over 4? Yeah, in between. And tan pi over 4, or tan 45, is 1. I wasn't having any sports today, but whatever. Okay, so basically, wherever that halfway point is on that graph, so that'll be pi over 4, tan pi over 4 equals 1. So that's going to tell me where I'm going to put 1 on my y-axis, and there we go. And then what we should also realize, that if our graph is very good, and I think I've realized that my graph isn't very good here, is if pi over 4 is 1, then 3 pi over 4 should be negative 1. So here's 3 pi over 4, which is there. So that should be negative 1, but I've done it a bit short there. So negative 1, if 1's up 1.5 lines, that means negative 1 needs to be down 1.5 lines. So my anchor point should be about there.
So if that's the question, why does 10x do you have the 1 and negative 1?
So that's what I was saying. You don't need to put 1 and negative 1. You only need to put 1. So but you do need to make sure that your tan 3 pi over 4 is at negative 1. Okay? You also need to make sure that tan 5 pi over 4 is at 1 secant, which again it was a bit off. So maybe what you should do when you're doing tan, rather than just doing 0, pi over 2, pi, 5 pi over 2, 3 pi over 2, 2 pi, maybe also do all the things in between as well. So 1, negative 1, 1, negative 1. So that way you can kind of sketch up there, hit that point, hit that point, hit that point, hit that point. So when we do a few tan graph questions, that's what we're going to do. So let's have a look at y equals 2 tan x. So what's going to happen here? Taller. I think higher kind of implies shifting up, whereas taller means you're like stretching up. But yeah. So again, we'll set up our axes. It's not like I need to make my y-axis twice as big either. So there's my 2 pi again. So therefore there's my pi right in the middle. There's my pi over 2. There's my pi over 4. 3 pi over 4. There's my 3 pi over 2. 5 pi over 4. 7 pi over 4. And what I'll do is, so this is going to, like the 2, rather than me plotting 1 and negative 1 this time, I'm going to plot 2 and negative 2. Alright? So I'll put it like maybe there. That's going to be my 2, that's going to be my negative 2. Alright? So first of all, what happens at pi? Well, what happens at 0? What happens at pi over 2? Asymptote. What happens at pi? Yeah, 0. Yep. What happens at 3 pi over 2? Asymptote. What happens at 2 pi? Yep. And then, so what I'm going to suggest you do with tan graphs, just so you get the shapes inside of it right. What happens at pi over 4? 2. What happens at 3 pi over 4? Negative 2. What happens at 5 pi over 4? 2. What happens at 7 pi over 4? Negative 2. Okay? Seeing that, and the reason why we're doing that is because you're kind of thinking in between each of these asymptotes is kind of like a mini graph. And when you're drawing a graph, you want more than 2 points. Okay? Or you want more than 1 point. So if we only have the x-intercept, even though we know what it looks like, just to make sure that it's not too thick or too thin or tall enough and all that kind of stuff, we'll just follow that. And so now, just like that. Like that. And look like that. That's about as perfect as you're going to get it. Because now, you're not only showing where your x-intercepts are, you're not only showing where your asymptotes are, but you're also showing 4 other points. Because you're now showing pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So this graph actually has 9 different features. That's not even including the numbers on the x-axis and the y-axis. So that's a very detailed graph. We're never going to expect you to have more detail than that. It's not too difficult. It's just really realizing what's happening on your x-axis, what's happening on your y-axis, and filling the information in between. Yep. So let's do y equals, I don't know, what do you guys want to do? Shifting left and right, up and down, flipping. Okay, let's do tan 2x. So, what's the period of normal tan? Pi. So what's the period of this going to be? Pi over 2. Right? The period's going to be pi over 2. And what's the range of this going to be? Well, yeah, so negative infinity to positive infinity. Or all real y. Okay? So, there's my 2 pi. There's my pi. There's my pi over 2. pi before, 3 pi before, blah, blah, blah. So what happens at, and what y value should I put on here? 1 and negative 1. This time we're not stretching it vertically again, so I might as well do 1 and negative 1 again. Even though, like, it's a tan graph, so it's not going to oscillate between 1 and negative 1. It's going to go way beyond it, but it's going to be good for us to plot that point. So, what happens at 0? Yep. What happens at pi over 2 normally? So, well, let me so that's pi over 2. What happens at pi over 2 normally? It's an asymptote, but now that we're squishing it, where's that first asymptote going to be now? Pi over 4. So what's happening at this new pi over 2? What's happening at 3 pi over 4? Because what's the distance between these two asymptotes? Pi over 2, which is what our period was. So that, remember, that's what the period means. How long does it take before it just repeats itself? So yeah, that means we're kind of alternating between x-intercept, asymptote, x-intercept, asymptote. But then what we've also been doing is we talked about we need to know what's happening in between the graphs as well. So that's actually pi of 8. You really don't need to plot that and put that in your number line as well. But that's pi of 8. We're going to put that there. Basically what I'm doing is I'm putting it in between my asymptote, my x-axis. That's at negative 1, 1. Negative 1, 1. Negative 1, 1. Negative 1. So now, this graph has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different anchor points, not to mention the 4 asymptotes. So I have 17 key features here. It's quite detailed. It didn't take me too long to do all those, because it all comes from me knowing those key features of the tan graph. So now, you can just draw that tan graph. Yeah, 3 pi before. So that's pi before, 3 pi before, yeah. Because on the normal tan graph, it's had pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. But because we're squishing it by 2, they're now all over 4. Yep. Because from there to there, that's what 0 to 2 pi normally looks like for tan 2x. But now that we've squished it, we now need to put back everything that was originally outside. So this could have been originally 0 to 4 pi, and then we squished it. So I mean, if you did need to sketch the normal tan x between 0 and 4 pi for whatever reason, it would look like this as well. Except obviously my numbers on the x-axis would be different. Maybe that works. Oh, shifting. Yeah, sure. Sure. Alright, I'll do a shift down and then I'll do a flip. So we have 10x minus 2. Okay. So what's my range here? Still all real y. Even though we're shifting it down 2, it's still going up infinity, negative infinity. Alright? Has my period changed? No, nothing's changed. Basically, taking the whole thing and shifting it. The y thing is will thing, yeah. And so we'll get to that in a second. So previously, where we sketched just 1 and negative 1, what we should now sketch is, yep. So that means when I'm drawing my x-axis, I should think about that. So rather than me like putting it in the middle, maybe I just, so I'll go down, so that'll be -1, so -1, -2, -3. So that's my x, so that's 2 pi, pi over 2, pi over 4, 3 pi over 2, pi over 4, 4, pi over 4, 7 pi over 4. Right, so what happens normally at 0 for tan x? 0. But now, where's it going to be at 0? -2. Because we're shifting it down 2. Yep. So now you know how you got -1, -3? What's 1 minus 2? -1. What's -1 minus 2? Or the other way to think of it is, if you know it starts at 0, so it starts at -2, and now it's just 1 above, 1 below. That's the other way of doing it. Yep. So now we have pi over 2 is still an asymptote. We have 3 pi over 2 is still an asymptote. We have pi is still it was an x-intercept, but now it's at -2. We have 2 pi, which was an x-intercept, but now it's -2. Where's pi over 4 going to be? Yep. Where's 3 pi over 4 going to be? Yep. You're not a little convinced, either. Sure. Yep. Where? Yeah, so that's we got pi over 2. We have that's pi over 4. That's 3 pi over 4. That's 5 pi over 4. That's 7 pi over 4. And obviously that's pi over 2, and that's 3 pi over 2 as well. Remember the other way to think of it is that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That's 4. I meant over 4, and I said that. But yeah, does that make sense? Basically the same thing. Look at your anchor points and then also your asymptote points. Or, not really asymptote points, but asymptotes. Except you now brought them all down by 2. And like I said, I don't need to write -2, -3 there. I don't even need to write -2. Or I don't need to write -1. I just need to have one of them there. Because if I know that's -2, say I wrote that out. If I know that's -2, from then I can infer that that's -1, that's -3. If I wrote this to be -1, it's bored, man. If I know that's -1, I now know that's -2, I now know that's -3. And if I just wrote -3 down the bottom, I now know that's -2 and that's -1. As long as you have one point on your y-axis and one point on your x-axis, everything else comes from it. You might as well do lots of points when you're sketching it though, because it just makes things a little bit easier. You're not going to get penalized for having too many points. You can penalize for not having enough. So, let's do a flip. So y equals -10x. So, again, what's my range? Or real y, yeah. The critical points are 1 and -1. But yeah, still. And then what's the period? 2 pi, pi over 2, 3 pi over 2, that's 1, that's negative 1, there's my asymptote, there's my asymptote, there's my 0, there's my 0, there's my 0. But now, where's pi over 4 going to be? Negative 1. Alright, so rather than me going up, I'm now going down. Where's 3 pi over 4 going to be? 1. And then negative 1, and positive 1. Again. So weird drawing negative 10x. Feels weird having to go down. But, so it's just the same thing, except it's been flipped. And just for fun, it's going to do it on the same graph. What's that going to look like? It's not going to be up 1. That's not a 1 minus, that's an absolute value. Yeah, it's not saying 1 minus, that's the absolute value. So remember what we did yesterday with that question? Yeah, basically we turned all the negative bits and we flipped it to positives. So what it would look like was some of the time it would look like positive 10x. So that would still be there, but then when it gets to here, it kind of bounce back up. So basically wherever it's negative, now make it positive.
You can do that. You can say you can.
I just did it as a different thing, but
If they ask you
if it asks you to sketch that, what you would do is you'd sketch negative 10x first.
if they say like on top of that, whatever, you just do it. Well, they won't answer that.
They probably won't ask you to sketch in the first place. Mind you, there was that HSC question that we did yesterday where we talked about where does like the absolute value of 3 cos x equal 1 or something like that, or how many solutions. So we needed to, it helped us by sketching it, but it's not, like basically what you do is you just sketch negative 10x or whatever's in the absolute value sign, and wherever it's negative kind of reflect it. So rather than kind of like curve down, I curve back up. Rather than starting at 0 goes down, I start at 0 going up.
If that says it equals 0, then you do 4.
Not 4, because that points is 5. So 3.
No, but if y equals the second.
So if you're trying to solve
that equals 1. No. Yeah.
or 1.
Yeah, 1.
Oh, well you did say 0.
Did I say 1? Okay, 1.
Okay.
Yeah.
Then yeah, 4. Yeah. So that'd be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi. No. Yeah. Yeah, because they're not really there.
Yeah.
But yeah, so if you're trying to, if the question is asking how many solutions does that have, 4. The question could, I mean, seeing that those answers aren't really quite hard to find, I mean, we know that the different versions of pi over 4, so pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, they're all either 1 or negative 1, but when you absolute value it, it becomes 1, as we can see. So it's halfway between pi over 2 and 0, halfway between pi over 2 and pi, so pi over 4, 3 pi over 4, 7 pi over 4, 9 pi over 4, no, 5 pi over 4, 7 pi over 4.
If there's like a question that has a lot, like, people want stuff like that, what do you think we should do? Like, because I like to write it first, like, why is that? That's why, like, what can I do without knowing it? Like,
Do you want to think of an example? Can you think of an equation that has a lot going on?
29. Oh, 30.
Okay, write it.
Y equals negative 2 cos bracket x plus pi over 2 plus bracket
I must have been a nice movie when I was writing that. So, I mean, what do you mean write down everything?
So, like, of course I'm not going to just draw that. straight away. So what do you do? Like the steps you have.
So each of those numbers is doing something different to the graph, right? Okay, what's the minus 3 doing? Minus 3.
Oh,
Yeah, we'll get to that in a second. So it's shifting it down. What's that minus at the front do? It's flipping it. What's the 2 doing? Stretching it vertically. What's that plus pi over 2 doing? Shifting it to the left. Alright? So what you kind of need to do is think of a cos graph that does all that. So think of the basic cos graph. Alright? Starts at and goes down and back up. Alright? So your normal cos graph, it's 1, 0, negative 1, 0, 1. Yeah? We're not swishing it. Alright, I could have made this question a little bit more fun by doing that as well. Alright? And then you're now doing all the 5 things. So
you just say picture it.
Kind of do one change at a time. Okay? So right now, if it's just cos x, we know what it looks like. If it's now 2 cos x, it's now between 2 and negative 2. If it's negative 2 cos x, we're flipping it. So still keeping that last shift that we just did in our mind, it's now starting at negative 2, and then going up to 2, and then back down to negative 2. Alright? The next thing I would think about is minusing 3. So now, rather than starting at negative 2 and then going up to 2, I'm now starting at negative 5 and going up to negative 1. Okay? We've done that. The only last thing that we need to do now is shift it 1 to the left. So rather than me starting at negative 5 and then going up to negative 1, I'm going to see now shifting it to the left. I'm now going to start at negative 3 and go up to negative 5.
What I did is I did everything one by one and I kept drawing it one by one.
Yeah.
That's fine.
Yeah. So you do like step 1 is
one,
increasing it. Step 2 is flipping it. Step 3, that's exactly what I'm doing, except I'm not drawing each one. All right. But yeah. So what you can maybe do here, I know shifting into the left and right is probably one of the hardest things. So maybe sketch it just without that for a second, and then from that, just shift it 1 over. Maybe even on your graph, you could maybe in black pen or maybe in pencil, draw everything except without that. Then in pen, shift it over 1 over, and then rub out your lead pencil. Alright? Or just visualize like shifted, flipped it, shifted, blah 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 blah. Guys, I'm middle classes. Huh?
Did it come out? Okay, good.
Probably gonna get that in here, so you want to go there?
Yeah.
Alright, cool.